So hello and welcome to Chapter 1 of Objects First with Java for our Object-Oriented Programming course. So if you have gotten through CSIT 103 or 105, and to be in this course you probably have, you're probably going to be maybe confused by using BlueJ as an editor, especially since you've probably figured out how to do things with NetBeans or with Eclipse. But I want to walk us through kind of why we're doing this and also introduce you to get us into how we're approaching this ramp up. This is very much review material, and as such you may go through it somewhat quickly. I want to start by saying that the focus of this course is not Java. The focus of this course is object-oriented programming. Java just happens to be the language that we're going to be using. So while we will use Java, and we will use Java inside of BlueJ, we will be thinking about objects. And the reason we're using BlueJ is it allows us to think about objects without necessarily knowing every last bit of Java that's necessary to make that happen. So where you may have built programs with 1, 2, or maybe even 5 objects in CSIT 103, by the end of this course, our projects will have 15, 20 objects communicating with each other, and these objects will be structured in such a way that they have a strong software engineering approach to how they're being designed. Ultimately, when you build software, you're probably going to inherit that software from someone else to begin with. You won't necessarily be building from the ground up. And that means that you have to build software that can integrate with that which has come before it, and that will be accessible and understandable for the people that come to that piece of software after you've moved on to other projects. So our goal here is to produce and maintain high-quality software systems and to begin to develop that discipline of thought that will allow others to figure out what we were thinking, what we were doing. And it's not so much that they have to read our minds. We're going to be very adamant about our naming conventions and about commenting and all of that. So in terms of what kinds of things we will be talking about this semester, some of them you might be familiar with, JavaDoc and collection classes, and maybe inheritance and overriding. But we're also going to be talking about responsibility-driven design, encapsulation, iterators, coupling, cohesion, mutators, polymorphic method calls, and a lot of other things. If these terms don't make any sense to you right now, that's okay. That's why you're in the class. But by the time you reach the end of this course, you should be able to give a very concise definition of each one of these that cuts right to their essence. Our goals then are to develop programming principles, not necessarily language fluency. By the end of the course, you should be able to think about object orientation and be able to approach solving a problem not by how do I make a computer understand me, but what objects do I need to make? And then once I know what those objects are, then begin to worry about how are you going to create the objects to do what you need them to do. We're not going to build massive systems, but we will be able to build a small computer system by the end of this course, and it will get you ready for courses like systems analysis and design. And you'll be able to implement that designed system using Java. So just again, the very broad view of what we're going to be doing. We're going to be looking at objects and classes, which you were introduced to in your introductory courses. We will understand how to define a class. We'll talk about how objects interact with one another. And while there are many different ways to get objects to interact, there are certain ways that will make it much easier to maintain those interactions. So it's not going to be so much can we get something to work at all, but can we get something to work cleanly? We'll learn how to group objects. through different types of collections that allow us to use different kinds of techniques to manage that information. We'll look at developing more sophisticated behavior by leveraging libraries that come with Java and from external sources. Along the way, we will learn to design our classes and make fairly complex classes that are tested and debugged and have a longer lifetime than just the project that you're working on at any given moment. We'll also, in the second portion of the class, talk about inheritance and polymorphism, which gives object-oriented languages such great power. We'll talk about how we can extend classes and build our structures, our class structures, so that they are not rigid, but can be modified and extended to meet greater needs. We'll talk a little bit about building graphical user interfaces and the different components that come to play there, although most of the time you'll be working with other libraries outside of Java to facilitate that. We'll make our classes robust so that they can handle errors, so if something goes wrong, it doesn't just crash to the control prompt or back out to the operating system. And we will begin to go through the process of thinking about a problem space to design an application in the very last class sessions. Now, Java as a language has been modified over the years. Any language needs to evolve, and part of that evolution has added some complexity and some would say some cruft to the language. It has adopted some ideas from languages that have come after it that had to be bolted onto the side, that are not necessarily following the same syntactical structure. And so we will talk a little bit about streams and lambdas, and we'll talk a little bit about sparse two-dimensional arrays. But we will skip most of that, and we'll come back to them when they're most important to us when we get to graphical user interfaces. The first concentration in this course is about classes and objects. So CSIT 105 students, I know that you definitely have addressed objects in your courses. And CSIT 103 students, you should have been introduced to objects as well. We're going to pick up working directly with objects from the start. And our purpose is to begin to extend that idea about what objects are and what classes are. BlueJ will assist us in that, and we'll see how that works in a bit. As you've probably been told, you could say that a class gives us a description of what a thing is, possibly a blueprint, or maybe you've used the phrase cookie cutter. And an object is something that has been built according to that blueprint and then is customized to describe a specific instance. So in order for us to do this, we're going to take a moment and explore what this looks like through BlueJ. Now, this is not through GitHub. This should be something where you can download the zip file of projects for Chapter 1. And there will be a project in there named Figures. So please do that now. There are a lot of items on my hard drive I'm trying to get into. Oh, well, this appears not to be working because my touchpad is getting touchy. Give me a moment. So here I am inside of that 242's projects folder. And here we have Chapter 1, and inside of Chapter 1, there is a project named Figures. What you will also notice is that there are many Java files and then class files. We'll talk about that in a moment. I am going to go to sort by kind. I'm going to get all my class files together here. I'm going to just delete those so that we can see just the pieces that BlueJ needs. A BlueJ project is a folder of Java files that has these ctext files which describe how the BlueJ interface is supposed to display those, and also a BlueJ package. So when you're downloading projects from GitHub, you will download a pre-created folder that has all of the components that you need. You might need to go ahead and add some additional Java files over time, but you'll be working with code that is partially built and adding pieces to that. Your Java source files, of course, are the files that end with .java. This README file, readme.txt, shows up in the BlueJ interface as a small icon for a small slip of paper, and when you double-click on that, this is the file that gets opened up. So I'm going to open up this project inside of BlueJ, and to do that, you can't see this because I'm on a Mac and it is up in the editor. I'm going to the project window and I'm going to choose Open Project, which will bring this up. And I need to find that folder, 242 projects. And go to Chapter 1, and if I point at the Figures folder and open that, BlueJ recognizes that as a BlueJ project. And so what we have is we have canvas, circle, square, triangle, and person. And these are the Java source files: canvas.java, circle.java, person.java, square.java, triangle.java. Readme.txt is this icon right here. And so this is something that is not part of Java, but often a good idea to have a README file inside of your folder. It's not part of the Java doc, which we will learn about later. And then the information about where to put these boxes on screen. Notice that the relationship between them and even the size, oops, if I click in the lower right-hand corner, that information is what's stored in the ctext. So, so those pieces are necessary, and you probably haven't seen them before. Now, I have gotten rid of all of the class files. If I go ahead and hit the compile button, all of these classes, Java classes, have been compiled, and their bytecode class files have been added to the folder as well. That means that now that these objects have been compiled, I can go ahead and begin making instances of those objects. Now, what makes BlueJ interesting is that I don't need to have a main. In fact, none of these classes have a main in them. BlueJ is going to act as my main. So let's say I wanted to create a circle. I can right-click on Circle and make a new circle object, and it's going to ask me to name this variable. I'm creating a variable at this point. So Circle 1 works for me. I will go ahead and create Circle 1. And now Circle 1 exists down here on my workbench. And because this is a Java class, because it's a blueprint or a cookie cutter, I can go and say I would like to make another circle object. And BlueJ knows that I can't name it the same thing, so it's going to suggest the name circle 2. So I could go ahead and also make a square. I will do that. You get the idea. In order to do this, I'm right-clicking on the object. It is pulling up a menu, and I am making a call to the constructor saying I would like a new copy of this object. Now, each one of these objects, now that it exists, I can double-click on it, and it will show me a set of values in its private variables. So a circle object is defined by its diameter and its position in the X and in the Y, and its color, and whether or not it is visible. So I can see that I have my circle object here. I can right-click on my circle. So that was by double-clicking on it. Double-clicking brings up the inspector. Right-clicking on circle will bring up the ability to call any of the public methods that the circle has. So, for instance, you can see that my diameter is 68, but I can call change size, and it's going to ask me for an integer value. Change the size to a new size in pixels. It must be greater than or equal to 0. This returns nothing. It's void. The name of the method is change size, and it takes an integer. I'm going to change my size to 110 pixels. When I click OK, and if I come back to the inspector, I will see that the internal representation of that variable, which used to hold 68, has now been overwritten with 110. So BlueJ lets us create objects, inspect what's inside of them without having to do a lot of system out printlns, and also to invoke the things that the object can do. I'm going to choose change color. Now notice change color expects a string, and it says I can use quote red, quote yellow, quote blue, quote green, quote magenta, and quote black. So it is currently blue. I'm going to make this circle, let's make this circle yellow. I'll put it inside of double quotes to make it a string. I click OK, and this circle string has changed from blue to yellow. So there are many different things that the circle knows how to do. Some of them are off the bottom of the screen, but right now I'm going to choose the one make visible. And I need to drag this window into my screen capture. When I made that circle visible, it created a canvas, a Java canvas, and it drew that circle for me. If I come back to the circle, move this over just a little bit so we can see it. If I right-click and say Make Invisible, the object disappears from the canvas. I'll make it visible again. I'll make the other circle visible. And that circle, when it was created, has a different set of parameters. In fact, I can check that. Here's circle 1, which is yellow, with a diameter of 110. Here is circle 2, which I didn't change with all of its default values, which has a diameter of 68 and is blue. So what I'm doing is I am interacting with these objects by sending messages to them through their public methods. Square 1, make yourself visible, and it does. Square 1, what are your internal variable states, your field states? This square has a size of 60, it's positioned at x310, y120, its color is red, and its visible is now true. So BlueJ is going to give us a chance to build objects, but not have to build all of the other software, all of the other supporting code in order to see if our object can work. We'll be able to poke at that information and ask that object to do things for us and tell us things about itself. So, for instance, now the figures example is highly visual. If I think I'm going to have to bring this down here so we can see it. I can tell the circle, I would like you to move horizontal, and I would like you to move negative 100 pixels, and it moves 100 pixels to the left. In this circle, I want you to move vertical, and I'm calling this, but it's off the bottom of the screen. And I want you to move negative 50 pixels, and it moves up. So computer graphics are interesting and sometimes weird. But this allows us to send messages and to explore with our objects. They won't all be visual and graphical like this example, but they will all be available to us to see what is happening. So with that in mind, that was our figures project. What I want you to explore as you read chapter 1 of your textbook is to pay particular attention to the concepts of objects and classes, methods and parameters, and data types. So, for instance, the class was circle, the object was circle 1, or the object was circle 2. The methods were things like change color, or move horizontal, or change size. The parameters were the pieces of information that had to be handed to the methods in order for the method to know what to do. Change color to, quote, yellow, close quote, or move horizontal, negative 100 integer. And so BlueJ will let us play with this and experiment with the way Java works, hopefully in a way that will help to solidify what you learned in your previous course. So while you probably have heard this before, it bears repeating. A class is a template for all objects of a similar objects of a kind. The example they give is a car. I like working with trees or dogs. But, basically could be any of this type of noun, let's say, or type of thing. And then a particular one of those becomes the object. These represent things in the real world. So a student class, you are an object of that student class. The desk that you are sitting at is your particular desk that is similar to all other desks, but unique to you in that it's positioned in your house and has maybe it has 2 wide legs, maybe it has 4 narrow legs, maybe it's black, maybe it has a glass top, maybe it's solid wood, maybe it's a standing desk versus a sitting desk. All of those are variations that make that a particular desk and would have to be something that the template planned for when the class was made. Ultimately, objects and classes of items need to have methods so that objects can be manipulated. And so if classes define the basis for objects, which are nouns, methods are often verbs, which are things that they can do. A method doesn't need to have a parameter. Like make visible, it didn't have to say anything. It's just making visible is either it's visible or it's not. So making visible doesn't require additional information, no parameters were needed. Others, like moving horizontal, well, how far should I move? To the left or to the right? And then it needs a parameter, it needs a value passed in so it knows how to do that. As you probably noticed, I had 2 copies of circle, only 1 copy of square, and I also had a couple of objects that I didn't invoke at all. Person or triangle. We'll talk about canvas later because canvas is a little bit special. So bringing those back in, we have several instances of the same class of object. Now, those objects have attributes, and those attributes were stored in a particular type of variable called a field. So the fields are the things that are tied to the creation of the object and can be changed over the lifetime of the object. It defines, so the class defines what the fields are, but you, depending on how the class is created, will be able to change the state of and the values of those fields to create a new version of that state. So again, double-clicking on an object on the workbench will bring up the current value of those fields, which are the private variables. And again, our circle object has the fields of type integer, representing the diameter of type integer, its position on the x of type integer, its position on the y, its type string, a description of the color, which is not the actual color value. For those of you that have had interactive multimedia, you realize that the color is handled with another set of values, and we will dig into that potentially next class. And there's also a Boolean field, which holds the should this thing be shown on the canvas or not, is visible. If is visible is true, then show the object. If is visible is false, then do not show the object. And so, as I demonstrated before, you can have different instances of those objects. Now, what I didn't demonstrate is that those objects ultimately did have source code. There was nothing magical that BlueJ was doing. It was interpreting the code that existed in those 5 objects to do what we were seeing be done. Now, source code is an agreed-upon way to communicate with a compiler of a language. While a computer language is an agreed-upon way to communicate to a compiler, and our source code attempts to communicate in that agreed-upon way. And when it goes well, the source can be compiled, and if it does not go well, that's where you get syntax errors. We will look at ways to examine source code for debugging purposes later. I do want to pop back into BlueJ and just show you, in order to create a new circle object, I right-clicked, but if I want to see the source code, I can double-click. And here I am in circle.java. And this is my entire class with the public methods that you're able to see when you try to invoke them. I'm going to slow that down for you. So, public class circle. Here are our private fields: diameter, x position, y position, color, and is visible. So this is what BlueJ is making visible to us that is not normally visible. Here is the constructor for the circle. So when I make a new circle, it's going to be of size 68 at a given location and be color blue. And here is the make visible method. So when I selected make visible from the drop-down, it came over here, and said, I'm going to set isVisible, which was initially by default is set as false. It's not assigned anywhere, but Booleans are false by default. That's actually a small oversight. They should have assigned that just to be sure. So set the variable isVisible to true, and then tell this object to draw itself. To make something invisible, erase it from where it currently is, and then set isVisible for this object to false. So there's some things happening. It just looks like make invisible, poof, it disappears, but it actually has to do the hard work of either drawing it on the canvas or erasing it from the canvas to make what the public interface looks like to be a default statement. And if I continue to scroll down, you can see that moving up, I call the move vertical method, passing it -20 pixels. Moving down, I call move vertical, passing it +20 pixels. And then there are also methods like move horizontal, where I have to give it a parameter. And then here are the 3 steps to make that object move on the canvas. I have to tell it to erase itself from where it currently is. I need to update its position to a new location, and then I need it to draw itself based on where its new location is. So these objects that were created and that hopefully you're playing around with, they're doing a lot behind the scenes. The nice thing is, when you work with objects, if an object is well created, you don't necessarily need to know how it's doing what it does. You just need to understand what kind of messages you can send to it and rely on it to do its job properly. And that's really the essence of software engineering. No one person writes all of the code. You need to be able to create objects other people can trust and to trust the other objects that people create for you. Now, one other thing that's important to note is that some methods are not return type void. Some methods give you information back. Everything in the figures project is a return type of void. But we're going to see in many of our projects, the important thing is that we ask an object to do something and it will give us a value in return. It might be a single value, it could be a collection of values, it could create a whole new object for us. And so getting this translation and communication of what do I need to give you, oh, and what are you going to give me back, is critical to designing object-oriented software. We will talk more about this in Chapter 2. Okay, you've been very, very patient. Here is the review of what we have. Classes, then, are written in Java, but they model concepts in the real world. We use the source code to implement those concepts and to come up with a data-based model to reflect what it's supposed to represent. And it's an imperfect model, and it's always an imperfect model, because we have to make choices. But we can choose the most important salient items for the problem domain we're trying to solve, and hopefully we do a good job of modeling it. I will say that just because something goes through a computer doesn't mean that the information that comes out is any more valid. So you need to keep that in mind as well. But we're going to focus on designing that source code, and we're going to define methods. What does the object do? And we're going to define attributes or fields, which determines what data they store, which allows the object to know what it is at a given time, what specific element or what specific description of that class it is at a time. When we create objects using a constructor, it is a good idea to set up some predefined values, and some constructors will see require additional information so that they can do their job. We need to give a pathway to the outside world to objects, and those are our public methods. There are also private methods that the outside world doesn't need to see, but might contain code that the object needs to also do its job. When we call methods on an object, it's either going to change its internal state, like we saw changing color or position, or it's going to use the data to decide what to do. Oh, now I'm visible, now I'm invisible. So that changed its state and also changed its behavior on the canvas. When you're creating your objects, some methods for your objects will not need parameters at all. It's just, I know what I need to do, you've told me to do it, I can do that. Other methods will be like, well, I need one additional piece of information, or I need 4 pieces of information. Or, hey, if you want me to do this, you got to give me 9 very specific pieces of information, and then I can make that happen. And you might say, really? And yeah, honestly, that will sometimes be the case. If a method doesn't return anything, its return type is void. But if a method's return type is not void, then either a primitive, like int or float or boolean, or an object, like a list or a student, or since this is part of game development, an orc army, needs to be returned. And so we'll talk about how to do that. Finally, in order to write Java software, you could get Java to compile and have everything in one class, but it wouldn't be object-oriented Java. It would be a terrible idea. It would be almost impossible to debug. Most programs will have many different classes doing small bits of the task, talking to each other in order to be able to complete a larger goal. And so focusing on how to build well-defined objects that do the proper task before them is going to be our focus this semester. Thank you very much for your time and attention, and I look forward to seeing you in the next lecture.